All right, welcome back. So we're going to pick up at in factoring, and we're going to move on to factoring trinomials, which I'm sure is not a topic that you remember with fondness from high school. Nonetheless, let's make sure that it connects to everything else we've learned so far. So just as a reminder, let's take a look at what we have been doing with multiplication and factoring. So what we have been working on has been this family triangle, and we have labeled for example, the vertical factor as one of the factors, and then the horizontal factor is the other factor, and the product is that rectangular area that we have been looking at. Rectangular area that we have been looking at in one of the quadrants. Now, so when we are going from factor to product, we're multiplying. And when we're going from product to factor, we're either dividing if we know one of the factors, or factoring if we don't. All right, so let's take a look. Just a couple of quick reminders about the multiplication. So let's say we have 2x times 2x minus 3. So 2x is our vertical factor. 2x minus 3 we'll use as our horizontal factor. And so our vertical factor will be 2x. And our horizontal factor will be 2x minus 3. Okay, so in order to fill the rectangle that is the area using those two dimensions, we're going to make sure that everything lines up. So here are, if we split up our region in this way, we're going to see 4x squared and negative 6x. So this would be 4x squared minus 6x. Okay, let's take a look at this one, D, for example. If we have 2g plus 1 times 2g plus 1, we will see that we have 2g and 1 and 2g and 1. And notice that what I'm doing generally is I'm putting the linear term, the actual rod, close to the origin, close to the center, and then the ones go on the outside of that. That's just kind of standard way that I organize my factors, mostly so that I could see any patterns that arise from in the product. If I just didn't keep the order constant in any way, then I might not see those patterns, I might miss them. So if we make sure that the product lines up with everything, we have 4g squared, and we have a 2g, and another 2g, and a 1. Not sure, but part of this is not registering. All right. So overall, we would have 4g squared plus 2g plus 2g plus 1, or we can simplify to 4g squared plus 4g plus 1. All right. So we've been multiplying out. Now, if we take a look at what actually happens when we multiply out two binomials, so two linear binomials, so y minus 2 or 3y minus 2 or 5y plus 7 times another one of those terms, and see if we can find a particular pattern. So I've done a whole bunch of them, 12, where I've multiplied the linear terms, two linear terms with, and you can see them here, 2x minus 6 times negative x minus 7, and etc. You can see them all, what I've actually multiplied, kind of at the bottom of each of the pictures. So you can see that all of these are binomial linear terms with a coefficient with a number in front of the x, and it could be positive or negative. So let's see whether we can see any of this, any patterns in the product. First of all, let's just make sure that I've done what I always do in terms of how I put out the factors. So you see that I've done the rods closest to the origin, and then if there are any singles, then I've put them beyond them. So here, for example, rods and rods. Well, the ones were the opposite sign, but you can see here rods, units, rods, units. So this is what I'm doing consistently throughout all of these. So we can look for patterns, assuming that that's what was done. That's the form of the factor that we were using. So let's take a look. I'm going to try to look for patterns here, and to do that, I'm going to see if I can highlight. So let's see, we have the squareds. They're all x's in here. So x squared, x squared, x squared, x squared. What do you notice about all of these x squared regions? What shape are they? Do you see is there any way that you can describe all of these, the shape of all of these regions? Do you agree that the region is a rectangle? Right? So we know now, we've known this for a long time ago, that the actual product is going to be a rectangle. And within that, somewhere is going to be a rectangle of x squareds. And it could be on the top right, it could be on the bottom left, it could be anywhere, but somewhere there's a x squared. Now, what do we notice about the rods and the ones? Do you notice that anytime that we see the x squared, either to the left or right are rods, and either to the top or bottom are rods. But what's kitty corner? Is that something consistent for all of them? Do you see that here we have the ones and the ones and the ones? All of the in the opposite corner are always ones. And what shape are those? Do you notice that those are also rectangles? So if we go back to here, we kind of see that this rectangle, however it's split up, it's hard to tell what the general size and shape of the rectangle, each of the rectangles is, but one of the corners is x squared, is these. And the kitty corner is ones, or these little guys. Now to the left and the right are rods. So if we look at a situation here and here, right? So we have kitty corner are x squareds and ones. Now we also notice that this could be rotated, this could be reflected in any way, but we don't know which orientation this is in. But we do know that the two of the corners are going to be rectangles that are x squared, and the other one is y's. Now let's take a look at the rods. Notice how many shapes, how many rectangles are there of rods in each one of these. So do you see the pattern? How many rectangles are there of rods? Well, these two are rods, so these are x's and x's. Right? The other diagonal is x's and x's. So one of the diagonals is x squared and ones, and the other diagonal is x's and x's. Well, what do you notice about these diagonal x's, diagonal rods? Do you notice that one of them is horizontal and the other one is vertical for all of them? Just check horizontal, vertical, horizontal, vertical, vertical, horizontal, vertical, horizontal, vertical, horizontal. Now, where are the vertical rods compared to the x squareds? do you see that they're always either to the left or the right? So they're to the side of them. So if this is our x squared in the top left, then the verticals will be to the side of it, left or right. And the horizontals will be to the top or the bottom. Well, it kind of makes sense because if we have vertical rectangles, vertical rods, then this side needs to line up with that side, right? So anytime we have this rectangle of product, everything within it must line up. So then the horizontal side, the horizontal rod must line up with the horizontal x squared, the horizontal dimension of the x squared. So it kind of makes sense that this is what the structure of all quadratic trinomials will look like. As products. So let's go take a look at some examples and see if we can use them. So now, are these quadratic trinomials? Well, here we're actually missing the ones, and here we're missing the ones, and here we're missing the ones, and here we're missing the ones. So we'll get back to those. Those aren't exactly trinomials, but this one is. So notice that you have, what did we do? The c squareds, and then we have the c, and then we have the ones. And these ones over here seem to all be positive, so they're all going to be in one quadrant. Now let's see whether we can make a rectangle from these terms where there are four regions, one of the c squared and the ones kitty corner to each other on a diagonal, and the other one is two rods on a diagonal. So I'm going to go back to this. Nope, not that one. And that one. And see if we can create something like that. So we had c squared, and then we had 5 c's, 2, 3, 4, 5, and 6 ones. 2, 3, 4, 5, 6. So you see that this is the product that we have to deal with. Now we need to make a rectangle with the c squared somewhere in one of the corners, and I generally put it into the corner with next to the origin. And then we have these ones. Whoop. Let me see if I can get. Okay. See these ones that need to be kitty corner somehow. Right? That's the only corner that they can be on. If it's on the bottom right corner, it will be in the negatives. Bottom left corner would top left corner would be in the negatives as well. So they can't really be anywhere other than this corner. Bottom left can't be there because then the rods would have to be in the negatives. But everything is in the positive, so it needs to be there. So in order to do a rectangle with the ones, we can either do a 6 by 1 or a 1 by 6. That's certainly possible, but there's also a kind of a more middle rectangle, and that is a 2 by 3. So if that's a 2 by 3, then it looks as though I should be able to create a rectangle that's this dimension. Right? If the yellow and the green are on the squares or on the diagonal, and the rods need to fit into the other diagonals, well, that's where the rods would be. So I could put 2 rods here, but then And then I have this other space, and 3 rods would fit in there, but they wouldn't be the horizontal rods. They would actually be the vertical rods. And if I fit them in, then what we do have is a rectangle with 4 regions, the x squared or the c squareds in one corner, diagonal to that are the ones. And then the rods are split between 2 regions. One of them is horizontal and one of them is diagonal. So let's go back to where we were writing this before. For some reason it closed on us. So what we would have is then the c squared with the singles, with the ones, and they're on a diagonal. And then we would fill the rods into these regions, into the 2 regions. So what you see is that the rods are actually 2C and 3C. They're actually split. Those 5Cs are split between 2 regions. And the factors, the vertical factor and the horizontal factor, the vertical factor is going to be our C plus 2, and the horizontal factor is going to be C plus 3. So do you see that pattern that we were seeing before emerging here as well? We have the rectangular product. We have 4 regions in it. One diagonal is the c squared or the ones, and the other diagonals are the rods. So one diagonal are the squares, the other diagonal are the rods. All right, let's try to do h. So we have x squared minus x minus 12. I'm going to go back to this graph. So x squared minus x minus 12. So we're going to have x squared minus x and minus 12. Some are 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. All right, let's get into here. So if we're to create this rectangle with squares on one diagonal and rods on the other diagonal, the squares, the green squares, have to be kitty corner diagonal to the x squared or c squared. So they can be on the top left here, right, with a rectangle, or they could be on the bottom right. So we can try to do one of them, and then if that doesn't work, we can do the other. We can try the other, but we know that there's going to be 2 diagonals. We also know that the rods will line up with this. So we could line up everything and do 12 by 1, right? Line them all up in one column. But then what's going to happen above the square, above the c squared or the x squared? There's no rods to go there. However, what if we did something like this? What if we did, instead of a 12 by 1, 12 could also be a 4 by 3. Right? So 12 could also be a 4 by 3. So then, in this situation, we have a gap for rods here and a gap for rods here. We could add 0 pairs to fill in some of those gaps. So let's see, if I take a rod, fill it in here, and another rod. So that's 2 rods on the negative. I could add 2 rods to the positive. And that doesn't quite do it. Oops. Let me get rid of this. All right. So that doesn't quite line up nicely. Instead, what if we try to, instead of doing a 4 by 3, what if we did a 3 by 4? And then let's see what happens with those. Okay. Oh, come on. I thought I had it. It was going so well. Okay. Because then we have a gap on the left in the negatives that we could put in a zero pair for. And look at that. That zero pair actually completes our rectangle. So what we have in this rectangle is our x squared minus 4x plus 3x minus 12. So let's go back and redraw here. So we had x squared, and then we decided that we were going to do a 3 by 4. So we had the one negative x from here, and then we said that we needed 3 x0 pairs in order to complete that rectangle. So what we actually are modeling here is x squared plus 3x minus 4x minus 12. So we've split this up into this negative x into 3x minus 4x by using zero pairs. And now if we look back to our factors, then we would be able to factor this into, our vertical factor is x plus 3, and our horizontal factor is x minus 4. Isn't that interesting? By knowing where the regions are going to be, we were able to create that rectangle to match the pattern and then to easily read off our factors. So let's do a couple more examples. Let's pick one with a coefficient that is not 1. So we have 2k squared plus 9k minus 5. 2k squared plus 9k minus 5. So let's go open up another one. So 2k squared. Oh my goodness. 1, 2 plus 9k. Oh, come on. Plus 9k. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then minus 5. 1, 2, 3, 4, 5, plus 9k minus 5. So let's see how we can do this. We know for sure that the 2k have to be a rectangle. And it could be a rectangle that is 2k by k, or it could be k by 2k the way it is here. We also know that the 1s need to be kitty corner to them. And we have 5, so either they're going to be all in one line this way. There's no other way to make a 5 rectangle. Oh, or all in one line the other way, vertically. Well, if this is the way where it was, if the greens were lined up this way, then we know that we would be able to place the 2k's on top of the k squareds the way I did, but then we wouldn't really have a place for the other 7k's, and we would have a gap in the negatives. So let's see if we can instead line them up. Maybe we didn't really test this out yet, so maybe they are actually lined up vertically. And if that's the case, then let's see if we have a place to fit all the k's. So these guys would line up here. These would line up there. And then we have a gap. We have a gap both in the positive and in the negative. So we could actually bring in a zero pair to finish this and to fill that in. So we needed one zero pair of k's. So let's go back to our picture. So if we have 2k squared, and we decided that, well, we tried the other way and it didn't work. So we found that going 5 by 1 does work, because then what we were able to do is fill this area with all but one, with all of the rods we had, but we found that we needed one zero pair. That would be the 9k and then the 1 0 pair. So the way that we actually ended up making this is plus 10k minus 1k minus 5. And if we want to now look at the factors, the dimensions of this, we could read off that that's k plus 5 and 2k minus 1. Okay. So I'm going to let you work. Actually, let's do P, and then I will let you work on the rest of them. So through page 27, and see if you can figure out how to factor these using the Algeblocks, not going back, not memorizing any of the things, or remembering any of the techniques that you memorized, just using the Algeblocks. So we have z squared minus 4. Let's go back and see if we figure out z squared minus 4. So we have z squared and 1, 2, 3, 4. Okay. So let's see how we can do this. Let's start with z squared being in the corner here. And then we have the 4 in the kitty corner, so diagonal. And notice that we don't have any rods. So if we were to use zero pairs, we would have to add the same number of rods to either side. So if we want to do that, then we better create the same gap in the top right as in the bottom left. So the same number for the positive rods as for the horizontal rods, and as for the negative rods, and the same numbers for the vertical and for the horizontal. So if we do it this way, if this is the way we had done it, then we would be able to fill both of those gaps with 2 positive horizontal z's and 2 negative vertical z's. And look at that, we actually have a square. The product is actually a square. So it looks as though we've got a perfect square situation. So what we did was we put the z squared here, and then the minus 4 in the 2 by 2. And then we brought in 0 pairs of negative vertical rods and positive horizontal rods. So what we actually modeled was z squared minus, or plus 2z minus 2z minus 4. And the factors for those were z plus 2, z minus 2, which is the difference of squares. Right. Interesting, very interesting that we can use very visual approaches to factoring trinomials, which was, I'm sure, something that was profoundly routine and procedural for you during high school. So as I said, I will leave the rest of them for you to practice. And if you have, or when you have questions about any of them, let me know and I will add some more explanatory videos for you to go over those ones.